and associate professor of geography, environment, and society at the University of Minnesota. Her research is in the field of population geography, and it highlights the role of context in various aspects related to maternal and child health, primarily reproductive health and family planning decision-making. Using her geographic training and quantitative background, thank you for sharing what you just did. That was really helpful to hear. She aims to build on past approaches and theories found in demography and public health. She strives to bring an alternative perspective to issues related to women's health and development through the use of a quantitative mixed disciplinary approach to the examination of the way that individual, family, or household outcomes are conditioned by place, including both the culture and the natural environment. She spends a considerable amount of time exploring underlying theories of development, resource use, and access, building on her own personal experiences and observations from time spent in poor countries and communities. Please join me in welcoming Professor Grace.
Thank you, everyone. Thanks so much for the introduction. So I will get started in half a second. I just wanted to tell people who weren't here that I did my undergrad at Berkeley. So, and I'm from the Bay Area, and my parents are all still nearby, sorta. And so this is one that I definitely wish I was there in person for. It's been a long time since I've been to campus. So anyway, it's love. And I didn't know demography. I was a math major and a French major. So it's great to it's great to be invited to this. It's really fun to kind of think back to those years and remember things like Berkeley time. Okay, I'm gonna get started. Well, first, actually, before I get started, I just wanted to check in really fast. So I'm on sabbatical and I've sort of forgotten how to do lectures anyway, so you'll see that. But can you all tell me, or just, in the chat or whatever, what kinds of courses you have on climate and demographic processes or climate change or weather or spatial analyses, anything? Nothing? Okay.
Not in demography itself.
Not in the department.
But in ag econ and places, there are some good courses.
Yeah, but it's not incorporated into the curriculum in the demography group. I mean, my point is just curious about it as I think about climate change demography and what we're doing as a field. So it's interesting to me to hear about it. Okay, yes, and I know there's a good geography department there. It's not quantitative, it's a little different, but there's some interesting classes there too. Okay, well, thank you for letting me know. I'm gonna give you all a bit of a crash course in climate change and spatial methods and spatial data, and you're gonna be like, wow, that's a lot. So we're just gonna do it though. Okay, let me get started and make sure this is the right one. Okay. Oops. All righty. Okay. So I'm going to talk about data, measurement, and pathways linking climate change and maternal and child health. It's really maternal, reproductive, and child health is kind of my area. So I'll be discussing a couple of those things. I think the best way to think of this talk is that mostly it's going to be a methods and data talk with this sort of under this umbrella of climate change and reproductive health. Okay, so hopefully I can kind of give you guys a little bit of insight into what's going on in the field, and then maybe, there's a ton of work that demographers need to be doing in this, so we can discuss all of that at the end too. Okay. So first of all, climate change will have the greatest impacts on health in the developing world. The WHO conservatively estimates that between 2030 and 2050, climate change will cause approximately 250,000 deaths per year from malnutrition, malaria, diarrhea, and heat stress. So keep those in your head a little bit. We'll call those pathways. We'll come back to that. But just kind of think about that. We're going to keep working on that. The World Bank estimates that climate change will push 100 million people into extreme poverty by 2030. So that's not too far away. I would say these estimates are all quite conservative. These are all kind of came out a little before COVID too. And I think seeing how global pandemic impacted the world and, exacerbated existing inequalities, and sort of that probably has changed the way we think about the impacts of climate change too. But these are sort of our conservative estimates. There's a bit of a spotlight on Africa, in part because there's already so many impoverished people, 422 million impoverished people. Another issue is there's 70% of Africans are small scale farmers, so they're dependent on rainfall. That means they need rain in order to produce crops and food to feed themselves and generate income for their families. So this is a heavy dependence on sort of this climate piece, right? And there's already high rates of malnutrition. 40% of childbearing women, 30% of children under age 5 are malnourished. So you can imagine if there's issues with agricultural production or disease, that people who are already sort of marginal in terms of health are going to be pushed into these sorts of extreme conditions, okay, or extreme outcomes. So let me tell you about definitions a little. I just gave a talk the other day for IUSSP on climate change and fertility, and I started this way with this slide also, only because I feel like this is an issue that we actually don't quite get in demography, what's going on in terms of the time scale. I'm also going to bug you to start thinking about how you would measure these things spatially. So what's the right spatial footprint? The neighborhood, the country, the community. Just think about those things. Start letting your mind kind of process some of those ideas. So climate change is associated with long-term average changes. You see this with like 2 degrees, the planet's going to warm by 2 degrees or 3 degrees or something like that. And temperature and precipitation. So you see warming and drying is the general sort of story. And that's going to happen over the next, however many years. So that's that long-term piece. Is that perceptible to you and me? A 2 degree warming? Well, that's a question. We can think about that. Extreme events are other things associated with climate change. And there's some question about which extreme events go with climate change, what are naturally occurring without climate change, that kind of thing. But extreme events like droughts, floods, heat waves, forest fires, those kinds of things would fall into this extreme events category and are also associated with climate change. Another area, which is where I spend most of my research energy, is on this idea of shifts in seasonal conditions. So this is an idea that there's going to be shorter or delayed rainy seasons or greater variability in rainfall conditions during the rainy season. So if you're a farmer and you're dependent on a particular set of conditions to produce the amount of maize or sorghum that you normally do, and it's shifting or it's unpredictable, that's the kind of research that I look at, is how does that impact the choices people make, the way they store food, that sort of thing. Okay, so those are 3 very different dimensions of climate change. And you could be a person who's exposed to all 3 in your life too. So just think that these are different sorts of processes that we're trying to understand. And I included this maternal child health blurb here. I'm assuming most people know maternal child health. It includes quite a range of factors: sexual and reproductive health, pregnancy, live birth events for calculating things like fertility rates, sometimes things like lactation or care practices. In this project, I'm going to be focusing on birth weight, and I'll tell you why in a minute. But low birth weight is when a live infant is born weighing less than 2,500 grams. Okay. So how do these pieces fit together? How does this climate change stuff on top and the maternal, reproductive, and child health stuff on bottom, how do those connect? And you can see with MRCH, I'm going to call it that, maternal, reproductive, and child health, that there are both short and long-term things, processes, ways that we think about these issues, these outcomes. And there are also with climate change. So maybe we can use that or think about that. So a while ago, a couple of years ago, I wrote this paper to just kind of lay some of these ideas out about how climate change might impact reproductive health. My focus was on poor countries. So I tried to organize all the literature, the older demography stuff that we all stand on, and some of the contemporary stuff in public health and with climate and that sort of thing, to just try to think about how these pieces fit together. So I organized it into this graphic. These are, handy frameworks. Of course, they're much tidier and simplified than the processes really are on the ground. But I won't walk you through it too much, but I will say that through this kind of framework, what we come away thinking about, and from all the literature, is that impacts can be through biological or behavioral pathways. Climate impacts can be through these biological or behavioral pathways. So people can change how they work, how they breastfeed, and that can have an impact on their health or their children's health or something like that. Or there could be something like a miscarriage that occurs. Or some other sorts of a heat stress type of event that can happen. Okay, so we can have biological or behavioral, but then we also have direct linkages, such as through heat waves, which is the solid line, which might have a really quick impact on a health outcome, leading to heat stress or preterm birth or even mortality in some cases. And then we also see indirect linkages that might operate through more distal causes like disease or food insecurity and inadequate nutrition. And that's this dashed line. And you see, as a geographer, I have to force you to think about scale. So we have individual, household, and local context, which could be really whatever we want to play with. Again, this can be made quite a bit more complicated than I have here, but just to help you see how these pieces can fit together. Of course, we're in a bit of a pickle because we don't really have data on all of these factors in ways that are really useful for pulling all of this apart. So that's where I come in with some of the research that I'm going to show you today. So this is a case study, and I'll show you sort of one applicant. I'm a big case study person. I really like examples. So through this example, hopefully you can see how we're sort of toying with pulling apart some of these things, trying to understand climate change impacts in a way that might be useful for humanitarian aid, for understanding sort of social and environmental processes and how they link. So this is a paper that came out relatively recent, I guess a couple months ago, in Demography. So you can read it there if you want, but I'll tell you all about it here and give you some extra stuff that's not in the paper. So this is a collaborative project. And I wanted to highlight that this is a collaborative project with people from I'm a geographer, but I'm a human geographer or a population geographer or health geographer. But we have other geographers on this project who are climate scientists who really are not thinking about population at all. They're doing climate stuff. I need them to help me figure out how to make the climate data, how to use the right climate data, how to use it in the right way, how to interpret it and engage with it. I also have this guy, Andrew Verdon, who's an engineer, who's very helpful for thinking about systems processes and also the interactions of these things. And then I have some friendly demography types too on it as well. So it's a big kind of group of us who are thinking about things in a different way and kind of came together for this project. So first, let me tell you a little bit about the background of climate and pregnancy health in Mali. The prevalence of stillbirths and low birth weight is higher in Mali than the global average. People in Mali are more vulnerable to local weather patterns because a large fraction of the population relies on rain-fed agriculture. And like I told you, rain-fed agriculture produces this, as you can tell, a pretty intense attachment to weather patterns and the timing of the growing season and the quality of the growing season and all of that. That's very important. I'll show you a graphic about it in just a second. And Mali really is one of the poorest countries in the world. And so there are quite a few people either directly engaged in rain-fed agriculture or who are very closely dependent on rain-fed agriculture for their livelihoods. Okay, so this is an important way that people live. There's not so many studies that look at the relationship between weather and pregnancy outcomes in Mali or sub-Saharan Africa more broadly. So there's kind of a lot of questions about how we understand risk and heterogeneity and those kinds of things and how people respond to that and the strategies that work sort of within the community. So there's a lot that we don't know scientifically anyway about what's going on. Now we have this other thing that's happening. So I told you the data. I created that framework. I love it, but the data, you and demographers are so good at being like, how do I work with imperfect data to help me understand what's happening on the ground. And so we're in a pretty neat position right now in the fact that there's a ton of climate, weather, land use, remotely sensed data that gives us a lot of information about what's happening on the ground in terms of land use and climate. And we can use all of that information actually to help us pull apart help us better understand the relationship between climate and health. And so historically, we haven't had nearly the type of data that we do now, and it is bursting at the seams. But it's a hard thing for us to figure out how to use it. And then the other issue that we have here, or the good thing, I guess, data-wise, is we have highly detailed pregnancy data, pregnancy and birth data, with place of residence information. So the place of residence information is really key for linking these processes. This is a really spatial way of thinking about climate. We need to know what people are exposed to in order to make sure that we're understanding or getting closest to understanding the impact of a climate or weather event on people's health. And so the more information we have about where they live and how long they've lived there really helps us. So often we don't have this kind of detail in the US or in wealthy countries, or we don't have the length of time at residence piece always. So we have quite a bit of information here that can be linked with this climate piece. But I will say, in the detailed information that we have on pregnancy and reproductive health, we don't have any information on ag, or virtually none on ag, land use, climate, or time use. So there's still a lot that we have to guess at still. I'll show you more in a second. So a typical approach to doing these kinds of analyses is to take, so climate data is something often like daily data for a pixel, and a pixel can be pretty small, 5 kilometers maybe, or smaller even. So daily data, and if you want, I won't tell you too much about pixels, but you can it's a raster, so you can think of it like a matrix. So it's just a lot of information that we have at pretty fine spatial detail, and we have that every day for maybe 20 years. So that means that's a lot of data, daily data for 20 years. And you have a 5-year-old kid or something. How do you put all that together? What exactly are you looking at? And again, think about the definitions or the factors, the weather conditions that are associated with climate change. There's a lot of different ways that you could aggregate that weather data, but you can't use daily data. It's just not, it doesn't work in the way that we all think about human processes or demographic processes. So we have to do something with aggregation. So in many cases, researchers use aggregated temperature and precipitation data, simply averaged over a season. So they might say, here's the growing season, I'm going to average it. Here's a year. I'm just going to take the average temperature over the last year, or the average temperature over the last month, and link this to child health outcomes. Temperature is a little tricky if you take an average of it, because something bad happens to your high temperatures. It gets lost in the average. And a heat wave can be as little as 2 or 3 days, 1 or 2 days of extreme temperatures or high temperatures. And high temperatures can just be over 100 or so, it doesn't have to be that, but it gets mixed up and lost in an average. So averages, and an average over a year, so it starts to get a little goofy, right? But that's what we've done in the past, is just because we didn't know what to do, and we were like, let's start somewhere, which is great. There's a lot that we've learned from that empirical work, but a lot of the relationships between what weren't even explained. So people weren't specifying, oh, I think it's heat stress and heat stress. They're just saying the average temperature, let's say, what happened, how does that relate to child health? Okay, so there's a few questions about what actually people are trying to test. Is it just an association? Do they have some underlying theory? It's not always clear. But of course, that's fine. No critique. It's just how we get started. So, but sometimes, and depending on the context and the temporal details of the measurement, the aggregation, the findings aren't consistent. So this is where it gets a little complicated now, is sometimes we see high and low, high values in one study, high temperature values in one study associated with a good health outcome, high temperature values in another study associated with a bad health outcome, low temperature values associated with good or bad. Do you see? And the same thing with rainfall. Like, we'll see kind of a range of outcomes because people are using all these different aggregation strategies. So it gets a little confusing. And then people will use reasoning for that. They'll say, oh, well, high temperatures are good because they increase agricultural production. And so that's why it's a positive for child health. Or high temperatures are bad because they're associated with heat stress. So that's why it's a negative. So we're right in the thick of it right now as we're trying to figure out, okay, how do we do this better? And how do we actually learn important information about what we're supposed to do next, or how to support communities on the ground who are dealing with this, or identify those most vulnerable, those kinds of things. Okay, so for this project, we're going to try to push this field forward a little bit. So the goal here is, can we use the vast amounts of highly detailed, fine scale spatial and temporal data to derive climate and environmental measures, climate or environmental measures that are more directly tied to the primary pathways linking climate and health? Remember, I kind of told you that there were going to be that to keep those pathways that the WHO mentioned. So we're going to explore those, although we're not going to explore diarrhea, but we're going to explore the pathways that are most commonly thought to be those that are linking climate and health. Okay, and we're going to see if we can do that better with the data that we do have, and really exploit the mass amount of data that we have. Okay, and like I said, this is a little tricky because sometimes these factors are related. For instance, sometimes hot weather helps crops, but it's also associated with heat stress. Or rainfall is really, you need a really good rainy season for great agricultural production, but hot and wet is perfect for malaria, right? So we're trying to figure out if we can pull those things apart a little better. How we kind of help ourselves out here is we pick a well-defined outcome variable, which is birth weight. And this is a good variable for us to use because we have a very defined exposure period. We know pretty well when the birth occurred, and we know pretty well when the pregnancy occurred. We're kind of guessing on the 9 months, but we're going to assume that. And we also look at that preconception period, just because that might be important. So we take the birth date and we look at we'll call it the 0th trimester, the preconception period, and then each trimester. So that is very handy for us, just to have a very defined period of observation. And then we pick a fairly easy country in terms of agricultural monitoring or remote sensing for agricultural monitoring, and that's Mali. So the nice thing about Mali is it's pretty flat as compared to a country like Kenya. And so some of these remote sensing tools work a lot better when there aren't shadows and other clouds and other things going on. So we have Mali is a country that works pretty well because it's so flat and because it has such a defined growing season. Kenya has multiple growing seasons, a primary and a secondary, and that can be a little bit tricky. Not all parts of Kenya either, just some parts of Kenya. So Mali is a lot more easy in terms of the variability around the growing season. So I'll show you what I mean by that in a second. So let me tell you a little bit more about the pathways that we're going to be looking at. And I kind of, like I said, mentioned them in that the WHO quote in the beginning, but we're going to be looking at food insecurity. And to do that, we're going to be using a measure of growing season vegetation. And this is used in the food security community as an early warning measure. Oh, this was a bad growing season. And so we think in a couple months, it's going to be a bad hunger season. So we're going to use that approach. We're going to look at the growing season of the past year, and we're going to use it as an indicator of how severe the hunger season is of the current year. Okay, and that's how it's used in the food security community. And this is a remotely sensed measure. I'll show you about the data in a sec, but I just wanted to tell you about the pathways. We're also going to look at malaria. So this is another one of those common pathways. Oh, rainfall, high rainfall is associated with adverse health outcomes. That's because of malaria. So we're actually going to model malaria a little bit better, or we're going to try to create an indicator of potential malaria exposure and a little bit using these climate variables. So we look at rainfall and temperature, and we consider them together to make sure it's the perfect conditions for the vector and the parasite. I'll show you more about that too. And then for heat stress, we're not going to use averages. We're actually going to use the count of days above a certain temperature threshold. Okay. And sometimes you see people do this too. So I was a little hard on the field, but there are definitely people, and you'll see this more among economists that they'll kind of bin temperatures into high values and sort of, 90 to 100, 100 plus. So we're going to kind of work with that idea, but we're going to count the number of days above 95 degrees, 100 degrees, 105 degrees, and use that as our indication of heat stress. Okay. And we have it set up. The timing is pretty picky for each of those. I didn't go into all of that detail, but do ask me at the end about how we thought about timing. Okay. But we shifted each of those pathways has a slightly different model and timing exposure that we considered, just so we could do our best to isolate it. Okay, so this thing here is a very handy tool. This is from an organization called FuseNet, which is funded by USAID. This is the Famine Early Warning System. And they started in the 80s doing remote monitoring of agriculture after those big famines in sub-Saharan Africa in 84, mostly in Mali and Ethiopia. And so this is now a leading group for agricultural monitoring and sort of climate impacts on agriculture. And what they give us is a thing called a rainy season calendar and a hunger season calendar. So this is typically when the rainy season happens in Mali, from about June to September, a little later, and harvest occurs kind of late in September. And then you have a lean season. So that time between when you harvested last year's food, you've run out of harvest from last year's, you've run out of storage, you've eaten all the food that you had stored from last year, and you haven't harvested the next year's. So that's this kind of extreme period right here. And so this is documented in other places, and it's how humanitarian agencies think about when when we're going to see the most malnutrition or the most food insecurity and need to act. So we're going to use those calendars as just kind of a period of time to consider when we're thinking about the hunger season. And over here is just Mali sort of depicted by rainfall and temperature. The bars here are for rainfall. So you can see rainy season lines up pretty well with the rainy season as told to us by FuseNet. And then this is temperature up here, temperature max. And the hot time of year is just a few months before the rainy season. So this is when we're going to see really hot temperatures, maybe 110 plus, and it's hot and dry and that sort of thing. And once it gets rainy, then it cools off a bit. So just to give you an idea of what it looks like in general in terms of rainfall and temperature trends. Okay. Data. So for this project, we're using DHS, Demographic and Health Survey data. I am making an assumption that you all know at least what DHS is. And if you don't, I'll give you hardly anything. So feel free to ask me at the end if you need more. The really important information that you need to know is that it is geocoded. So that means it's spatial, and has a lot of detail about reproductive health. And so we're using 3 surveys for Mali, 2 from 2000, 2006, and 2012. They're spatially referenced clusters offset up to 10 kilometers. I'll show you what that means in a second. And one of the great things about DHS is that it includes this length of time at current residence adjustment. So we can actually make sure that if the child is 3, and we're trying to look at their birth, their conditions around their birth, and the mother who's responding to the survey has only lived in the community for 2 years, then we can't link that child. We don't know where that child was. We don't know where that mother was when she was pregnant. So we can use that length of time to help us make sure that we're getting closer to matching weather conditions to pregnancy. Okay. So this is where you're going to be like, oh, remotely sensed data. I never took geography because I didn't care about this, but you just have to know about it just a tiny bit. So NDVI, Normalized Difference Vegetation Index, is this thing that we're using for growing season or vegetation. Okay. This is standard. NASA produces it. You can get it from the website. It's all publicly available. It's got a lot of detail going back from 1981 to 2015. So we have a lot of information about vegetation on the ground across the planet, really. Spatial resolution is 8 kilometers. I know most of you are like, I don't know what that means. That's okay. I'll tell you enough to help you know why it matters. And then we're going to look at the seasonal maximum in year T, like I told you. So this is how they do it in food insecurity work, or at least one of the ways to do it. So we're not introducing anything crazy or new. We're taking stuff that exists in other disciplines and thinking about it here. For precipitation, we're using something that's created by friends of yours down south at UCSB, the Climate Hazard Center down there. They produce a lot of really amazing precipitation data. I actually think they might use some of Berkeley's data for generation, but maybe I'm wrong. Anyway, so this is the Climate Hazards Infrared Precipitation with Stations data, also publicly available. It's 5-kilometer data and every day for the past 30 years. So we're going to combine that with temperature data for a malaria index. And then for temperature, we're using something called Princeton's reanalysis. All of this is publicly available, but look at this. This is 50 kilometers. So we have a couple different spatial resolutions, which we always do in this kind of work. And it just means we have to think about our processes a little bit and make sure we're considering, we're not being overly detailed where we don't actually have the information. And that's every day for the past 30 years. And we're going to use this for a count of hot days and malaria index. The weather-based malaria index is essentially making sure that it's been hot and wet enough to make sure that these are suitable conditions for the vector and the parasite. And we have to use this because we don't know if there was malaria during the pregnancy. We don't know, there's no malaria record that links up with the DHS data. There's no way for us to know if the individual had malaria. We can only say they lived in a place that had conditions that would support the presence of the parasite in the vector. And so this has been explored in we're taking this from other people who have done a lot of work on this and to develop this kind of indicator. Okay. Another set of data also from FuseNet is called livelihood zone data. So here's Mali up here. Here's all these little polka dots, which are DHS clusters. So spread all around here. And we have very coarse aggregations here just to tell us the general trend of what people do to produce food or money. So we have pastoralists in the north, croppers in the south, and sort of animal and cropping going on in the middle. And really what this tells us too is it's drier down to wetter. So there's a north-south gradient of rainfall and temperature in Mali. That's fine. It's just going to give us something to be like, what is sort of normal here? What are people generally used to? Okay. So that's a handy tool for us to use too. Now, this is the thing I was promising you. Here is what we're dealing with in terms of the spatial issue. So here's where a DHS cluster, we're told the DHS cluster is. We have a latitude, longitude for where we think the center of the community is, center of the sampling area, enumeration area is, but it could in reality be in any of these spots. It's offset up to 10 kilometers. So this is where we're told it is, but it's not really there. It's somewhere else. So we have to deal with that because so it's easy. We take spatial averages. There's a lot of work on this. I've written a few papers on how costly this is or how much we lose by this, but I just wanted you to see the spatial structure. So we have households and individuals in households and respondents and children within those households, all within these clusters. Okay, so that's a little bit, that's just giving you, helping you visualize the spatial linking that's happening here. Okay, so the other thing, we also have this little window that we're looking at for each pregnancy, each live birth. We're trying to just make sure that based on where the child lived or where the pregnancy occurred, when it occurred, and then we can sort of link up we can get the details of what those different pathways were, what was going on in terms of heat stress during the 3rd trimester for this woman who was pregnant in this community at this time. So it's really an individual matching based on timing of pregnancy and place of pregnancy. Okay. Okay, and you could do all these other things. There's a million different questions you can ask using kind of this retrospective type information that exists in the DHS. So definitely let's talk all about different ways to use the DHS data. So we ultimately used just basic OLS regression with continuous birth weight as an outcome variable. We clustered our standard errors at the level of the mother. Our control variables are pretty standard: maternal age and education, infant sex and birth order, household floor material as sort of an indication of wealth, a very coarse indication of wealth, month and year of birth, and livelihood zone. Okay, so those are all of our kind of control variables. And we also use length of time at current residence. And I'll ask me more about that if you want to know what happened with that variable, but it was fine. We just double checked everything using that. We also, so in addition to our pathways approach, we also are using this sort of typical approach, which is just taking the average rainfall, average temperature. What if we just did it that way? What do the relationships look like? And of course, because, you know, we're us, I tried about 9,000. Well, we thought about a few different ways. Should we be using generalized additive models? Should we be using multi-level models, categorical birth weight? Are we getting something wrong by, should we exclude first births, only first births? So we thought about a lot of different processes that we might be able to capture in different ways using different methods as well. Okay, I will not give you any regression tables. I will only give you plots. That is my gift to you, although I'm a table fan. So these are set up in trimesters. So we have third, it's kind of in a funny organization, third trimester, second trimester, first trimester, 0th trimester. And what we have, this is food security, so agricultural production. A better growing season is associated with higher birth weights, okay? And what we're looking at is when the third trimester occurred during the hunger season. That's kind of how we matched that up. So if the previous year's growing season was better or was worse, then we see food. Yeah, if the previous growing season is better, we see higher birth weights. Sorry. Okay, for malaria, look at this. This is, well, I want to tell you everything, but you'll have to wait a second. So for malaria, what we see is, again, third trimester, second trimester, first and 0th. What we see is more when the pregnancy had more months that were malarious, we actually see higher birth weight. Okay, and that's primarily true for the third trimester, when the third trimester is more malarious, and maybe a little bit in the 0th trimester. Okay, so that's positive. For heat stress, hotter temperatures are associated with lower birth weights. Okay, and that's especially true for the third trimester. Now, here's the typical or sort of average approach. And this is for temperature. So just taking the average temperature conditions over the third trimester, second trimester, first and 0th, it actually doesn't look that different, right? And really it isn't that different when we kind of, when we're not just eyeballing it, it's really not that different. We're pretty much capturing the same, more or less. The results look more or less the same for temperature, okay? However, when we look at average rainfall, which is often how people look at it. They look at average rainfall. They're not trying to sort out malaria or food. They're just looking at average rainfall. So if we took average rainfall during each trimester, it's not telling us much, right? It's a little weird. And it certainly doesn't correspond to these other stories or these other stories that are emerging from the data. So there's something very different happening when we average rainfall than when we work through this pathways approach, okay? So summarizing the results, hot days are associated with reduced birth weight, which is very much consistent with other literatures. Better agricultural seasons are associated with higher birth weight, probably through this hunger season severity pathway. Greater exposure to malarious month is associated with higher birth weight. Okay, that's wacky. So what is going on here? We've certainly seen this before. And, you know, maybe you all are thinking about, what is that called? Heterogeneity's roots isn't that the classic Vopel? And yeah, okay, right. Yeah. I got some head nods. I love a head nod. So yeah, something funny is going on here. So luckily I hang out with people who like to think a lot about heterogeneity. So we poked around at that a little bit. So when we look at, we're going to check selection. So we look at male versus female births as evidence of selection. And indeed, what we see is that more malarious conditions during the third trimester are also associated with the reduced likelihood of a male birth. So perhaps we're seeing an increase in stillbirths or something, or perhaps that's happening, and that's what we're seeing the outcome of. So there's the most frail fetuses are not surviving to birth. Or not coming there, there's no live birth. Okay, and then also, what about miscarriages and stillbirth? We have some information on spontaneous abortion in DHS. There's some questions about it, but there's definitely some data. So looking at that data, we actually do see that more malarious conditions increase risk of non-live birth. So miscarriage or stillbirth, spontaneous abortion beyond month 2 of gestation. So that can be made, that's another idea that perhaps what we're actually seeing here is a selection effect. Oh, there's a chat. Okay. Oh, good. There's lots of questions in there. Okay. So study conclusions and applications, specifying the pathways and deriving measures from different types of environmental data that are designed to capture those pathways may provide us greater insight into the ways that climate impacts health outcomes. Their malaria indicator probably is going to work better in areas where malaria is not endemic. Temperature doesn't seem to need this like touch that we gave it, but that might not be true in other places. Mali is hotter than a lot of other places, and maybe in places where there's a little, where the temperature patterns are a bit different, then maybe that would matter more. So we want to test that in other places. But definitely it helps us think a little bit more about pathways relating to rainfall, what's going on, especially because the food production and malaria production or malaria are happening at different timescales too. So like a bad agricultural season doesn't immediately have a food insecurity impact. It takes some time. So we want to bring that understanding of food production into our modeling. And this might be one way of doing that. Okay, there's lots of other ways that we can think about using measures like vegetation and agricultural productivity to give us more insight into food insecurity impacts too. So that's another area to explore. So beyond the Mali case study, this ongoing effort that I think a lot of us are thinking about is inequalities start before birth. And so it's really vital to start thinking about climate change and social injustice and how these exposures in early life may have really significant impacts for household development, household economics, household health that we really need to be aware of and start working to mitigate. Big problems require data, methods, theory, engagement with different disciplines and stakeholders. So definitely math, statistics, remote sensing are really awesome tools, but so is spending time on the ground. That's part of what happened here is I knew rainfall was so important because I had talked to all my West African connections, the time that I'd spent in West Africa. I'm like, I know people depend on this, but I'm not seeing this in these models. What is going on? I'm clearly doing something wrong. Maybe I can get this better. Data truly, I just have to say, is fundamental. It shapes the types of questions we ask. The data quality or data collection shapes the kinds of data we have access to, and quality and access to data is unequal. And data access shapes who gets to do research. So our ongoing efforts to make sure that we think about data sovereignty and who gets to ask these questions and drive these surveys, I think is really important to consider too. Okay, thank you.
Great, thank you so much, Kathryn. That was super interesting. We have a few questions in the chat. Maybe we'll take the first question from the chat and then we'll give the grad students a chance to ask questions since they're not in front of computers and they're watching on the screen in the seminar room. So Ron, did you want to ask a question?
Hi, I really enjoyed your talk. I'll mute my video too. Sorry about this, I can't. Okay. I was thinking that the effects of high temperatures or low temperatures and perhaps rainfall would vary by season, which I've seen in historical data I've analyzed, so that a hot temperature in winter goes with higher fertility, a hot temperature in summer goes with lower fertility, and that kind of thing. So I'm wondering whether in the specifications you're estimating there's a allowance for different coefficients by season, interactions of effects with season of year, and that sort of thing.
Yeah, I mean, that's a thing that comes up a lot in review is a lot of requests for just double checking that there's an interaction by, month and place to, so in all of our work to kind of make sure that we are considering sort of seasonal norms and how that particular day or month related to a seasonal norm. So we've used that in a few different ways in how we've set up just making sure that we're only comparing January events to January births to January births or whatever. We have never seen that is sufficient for, that's not capturing what's going on, but it definitely keeping in mind that there's a norm for January and we're looking at some deviation from January's norm is an important part of this research for sure. Yeah.
Thank you.
Thank you.
Great, thanks. I think maybe Will had a question.
Yeah, thank you. This is fascinating research. Excellent presentation. Really enjoyed it. I really appreciated that you zeroed in on one country, Mali. I was looking through your population environment study from last year that looked across lots of countries, which is terrific to be able to do. But it's nice to be able to think about one place, and particularly in terms of types of behavioral responses to this, and one that I'm curious about in this particular context, since we are at least in one country, it's a big country. But what can you say about behavioral adaptations? For example, seasonal migration. How much scope is there for people to move in with relatives in the town or something like that, where they can take advantage of sort of informal networks to avoid some of the worst implications of a highly variable season?
Yeah, that's a really good question. And I think that's part of why we were interested in one country, because you're right, like doing 30 countries is just kind of unsatisfying when you're like, what are people doing? What's going on? And can I better understand that here? So we can't. So I have two answers, I guess. One is we don't have any detail on that in this data. So we don't know about we don't know anything from the data. What we do know so I'm fortunate enough to have done some qualitative work and worked with anthropologists who have done much more qualitative work in Mali and Burkina. And from that, we know, people might be moving around sometimes. People with first pregnancies, they're probably not. With, it really, really, really depends. It's often probably not the woman moving around a lot and the trips are short. And it's migration too, which has been around for a very long time as a strategy for managing, seasonal variability in labor demands. The way that it's shifted a little bit in terms of gender dimensions and that sort of thing over time, but it is definitely like there's family patterns and community patterns that vary over space quite a bit. And we don't have that kind of data. So I think you're totally right. Like getting more information on short moves, moves less than 3 months and that kind of thing. So the work that I've done qualitatively asking women about how they timed pregnancies to optimize their health, especially among poor women who are working in the fields. They definitely were like, it's not great to be pregnant, to have a big belly and like bent over in the field when it's hot and like, that's not ideal, but it's also not ideal to have a new baby during the hunger season. So there's another paper we wrote on that. So there is some, discussion around timing babies or pregnancies to be more optimal in terms of the growing season. But even in that work, we didn't hear much about people saying, yeah, I'm going to leave town for a couple months, but we weren't probing for that kind of information. So I definitely think thinking about the mobility and sharing family resources and all of that would be really helpful to better understand safety nets and strategies that families and households are using to, guard their health. Definitely.
Thank you so much. So I think we have time for one more quick question from a grad student, and then we'll also have a brief conversation with grad students right after this, led by Pyle. So can I turn it over to the seminar room?
Sure.
Yeah. Hi. I'm a first year demography PhD student. I just have a very quick technical question for you. So I saw for temperature data you were using the Princeton data. And but the climate hazard center actually have charts, which is like high resolution as chirps. I'm just wondering what's your thinking not using that one?
Yeah, that's a great question. So that guy, Andrew Verdon, actually was the producer, or like one of the developers of Chirps and Chirts. So the second author, so that's great. And I think this paper helped push them into producing Chirts daily. So at the time we did this paper, they didn't have Chirts daily. They only had Chirts monthly. And so that required a new paper, which just came out, I guess, a year ago or so on Chirts daily. But yeah, so that's another, that would be a way that we could update this analysis, is if we use this finer resolution, spatial resolution temperature data for sure. Yeah, so that was it. It just wasn't ready when we were ready.
Okay, thank you.
You're welcome. But yeah, definitely you all should use Chirps and Chirts. There's a nice R package to download it and link it with this stuff. So yeah, it's a great data set.
Wonderful. Thank you so much. So as I mentioned, I think Kyle will lead a grad student session with Professor Grace in a second, but for the rest of us, please join me in thanking her for a wonderful talk, and look forward to seeing you all next week too. Thank you.
Thank you for having me, everyone. Thank you.
So for the students who are staying, we're just going to stay on the same link.